We are fixing to do, let me flip my screen real quick. We are fixing to do 13.2, which is factoring trinomials. Chapter 13 is all about factoring and different techniques to factor. What we've done so far in chapter, I guess you would say in 13.1 was just learning how to factor by grouping, as well as just looking about the process to find the greatest common factor, actually divide all the terms by the greatest common factor, and our answer is what we would call our factored answer. So just trying to get a little comfy here. I think I did it. Let's start. So this will be 13.2, which is factoring trinomials. There's actually a lot of upside down S, a lot of things I'd like to write as far as like the process and the steps on how to solve this type of problem. The first thing I'm going to do is just solve a problem, kind of talk my way through it. And then after that, I'll go ahead and I'll list the steps. Okay. And then I'll probably have about 2 more videos for a total of 5 examples for 13.2. Okay, so like I said, let me just do an example real quick. You're going to probably question some of my steps, and then I hope that whenever I explain everything afterwards makes a little bit more sense. It's just better than writing a book from the get-go and losing some of y'all. Okay, so we're just going to go ahead and call this our example 1. And it is actually the trinomial x squared to positive 10x. We have a positive 24. So what we do when we factor trinomials, I know this is a trinomial because it's in the correct form. Tri meaning 3, and my leading variable, it's of the second degree. So, what we're going to do is we're going to identify our A, which would be the coefficient on my first term, which is just 1. My B would be the coefficient on my second term, which is 10. Be sure you pay attention here to the signs. If it's negative, you do need to include that negative. Our C is that third term, which is 24. And then the process that we're going to follow, and I will explain the steps after this problem, it's actually going to be called the AC method. Okay, so I'm going to go just kind of, what we're doing here is the AC method. Do you see how the letters A and C are touching? Well, that implies multiplication. It is called the AC method because after we identify our A term and our B term, what we do is we multiply A times C. So here my A is 1, and then my C is 24. So we're literally going to multiply those two together. If we do A times C, what we get is 1 times 24, which is 24. Signs are the same, so it's positive. And then what we do is we are going to actually factor that number, the product that we just found. We're going to factor it. And so what I mean by that is it's kind of like a capital T. I hear something vibrating. I don't know what it is. So it looks like a capital T. We're going to factor this product that we just found. And what you're going to do is you're going to list all of the different combinations of numbers that multiply together to give you 24. So I know for a fact 1 times 24 equals 24, right? Now if you divide 24 by 2, I get 12. And that's because 2 times 12 equals 24. And then let's go ahead and move on. I would do 3. And if you divide 24 by 3, you get 8. I know that if I do 4 times 6, I also get 24. So 5 is actually not a factor of 24 because I can't multiply 5 by anything and get 24. And then the next number that I would get to is 6. But if you notice, I already have 6 listed. There's no reason at all to list them multiple times. So what I would do is just stop right there. Those are the factors that multiply together that gives me 24. Now, our goal is to look at these factors and try to figure out how can I combine them? Not all of them, but I'm going to find a pair, right? And I'm wondering what pair can I combine that will equal my B? So if you look at where we identified our A, B, and C, I wrote down that B is a positive 10. So let me look at the factors and let me try to see what could I combine together. Y'all, because these are both positive, what I'm doing is I'm just adding them. But if you do have some negatives, you'll usually just hear me say combine because it means do whatever it tells you to do. They're both positive, then what's happening there is addition. It actually, don't want to be confusing, but if they're both negative, what you're doing is addition. It's when there's one positive and one negative, depending on how it's written. It could be subtraction, it could be adding a negative number. Instead of saying all of those words, I just say combine. Look at the signs and take the appropriate steps. Both positive. If I combine 1 and 24, I get 25, right? That's not 10. If I combine 2 and 12, I get 14. That's not 10. Now, what about 3 and 8? I would get 11. That's not 10. But right here, these factors, 4 and 6, if I combine those together, I get 10, right? And doesn't that equal my B? And that's what I was looking for. What pair of these factors that multiply together to give you 24 will also simultaneously at the same time combine together to give you your B? And what I learned is that those two right here, 4 and 6, they satisfy both of those stipulations, correct? Okay, so what I'm going to do now is this original trinomial, I'm going to rewrite it, but what I'm going to do is I'm going to expand that B term with these factors, 4 and 6. Now, whenever you expand your B term, if you look, that's not just a 10, that's a 10x. So whenever we put our 4, it also needs to have an x. When we put our 6, it also needs to have an x. And that's because I would actually need both of them to have the same variable so that when I did the combination of the two, 4x plus 6x, what I get back to is the original b, which is 10x. Okay, so don't forget your variable. Okay, so I'm literally going to switch back here. This first term just remains. I'm going to scoot. I know what I'm doing. So I'm going to scoot over just a little bit. This first term is going to stay. It's going to remain x squared, right? I'm going to expand. I'm going to rewrite my positive 10x with a positive 4, don't forget your variable, and a positive 6, don't forget your variable. Your last term just gets brought down, sign and all, okay? Do y'all see how if I combine these two right here, what I get back to is a positive 10x? The fact that that's true means that mathematically, I have not altered or changed this trinomial at all. It is still the exact same trinomial, it's just written differently. Well, the reason why I even needed to do this in the first place, in 3.1, we learned how to factor by grouping. So the reason why we learned to do that is because that's now how you finish this problem. Okay, we multiplied our A and our C. We found factors of that product. Then we chose a pair of factors that both combined together to give us B, as well as multiplied together to give us the product, right? A times C to give us that same product. Now that we have 4 terms, what we do is factor by grouping. In the end, you should have a number of different parentheses. We call those factors. That's why this is called factoring, okay? So let me go ahead and do that. The first step that I taught y'all was to split it down the middle, okay? Don't do this. Just real quick, what was that sign in front of the 6x? I just talked about it 27 million times. We remember it's a positive. But if anywhere along this problem you are trying to think about, the current step you're on and you forget something, it's very easy to lose that sign right there, correct? So I will always say never use parentheses because you will accidentally forget what sign was there, or you will just forget to bring it down. So instead, what we do is just one little simple slash. Now, we're going to actually group these, right? Factor by grouping. We're going to actually group these in 2 pairs. I'm going to pull the GCF out of the left-hand side, and then I'm going to pull the GCF out of the right-hand side. Okay? You only care about this side you're working on while you're working on it. So if I look at x squared plus 4x, and I think about what do they have in common, the only thing they have in common is just an x. Now you do division. You do x squared divided by x. Well, x squared divided by x, the exponent rule tells me to keep and subtract. And then here you're going to do a positive 4x divided by x. So, y'all, that coefficient in front of this x right here, whoop, that's a 1, right? Okay, so 4 divided by 1 is 4. Signs are the same, so it's positive. X divided by x becomes 1. So there's not a variable there. You just close your parenthesis. Okay, now look right here. Very important step. Whatever sign you have here has to be written right now. Now what we do is we look at the second 2 terms. We see what they have in common. That's their GCF. And then we divide both terms by our GCF. So if you look at 6 and 24, the largest number that's going to equally divide both of those is just the number 6. If you look at 6x and 24, you need to ask yourself, do they both have an x? No, they don't. So they don't have that in common. What you do is just start your division. So 6 times 6 is 1. Signs are the same, so it's positive. X divided by no x is still just x. 24 divided by 6 is 4. Signs are the same, so it's positive. So there's 2 ways you can go about it right now. You could either pull a GCF again, went over it in video 13.1. You would recognize that our terms are always divided by operations. And what we have here is a positive sign. So what that tells me is that this is all one term and this is all one term, correct? And if you look at both of those terms, what do they have in common? Yeah, that factor, right? That set of parentheses, that x plus 4. So what you would do is pull out what they have in common, right? They have an x plus 4 in common. Now, after you pull out the GCF, what you do is you divide everything by your GCF. So, same steps that we've been doing, open parentheses and do that division. X times x plus 4 divided by x plus 4. Well, our x plus 4s cancel because they're the exact same thing, right? So the only thing that remains is just an x. And then let's scoot over to this second term. 6 times x plus 4 divided by x plus 4, same thing. The x plus 4s cancel. So the only thing that you have left is just a 6. And y'all, that's a positive 6. Don't forget that sign right there. That's why we brought it down. That's usually about where common mistakes will happen, is there. Now, if you're okay with me showing you the alternative way right now instead of later, it's definitely not as technical per se, but it may simplify this last step just a little bit. Okay. And if you can ever cut a few seconds off of a problem and still get it correct, like that adds up, right? Okay. So I've gotten to this step and I've already pulled out my GCFs and I've already divided each term by the GCF, and now I'm here. What you do, you technically need to check to make sure these parentheses are the same either way, but for sure, right now, I need to know that what's in the parentheses on both sides are the exact same thing. I need to check it, make sure they match. Now, if I look, x plus 4 and x plus 4, yes, those are the same. Okay, so this is what you do. Parentheses are the same. I only need one. And then what's left over? Put it inside of a set of parentheses together, and you're done. That would be your final answer. Now, you can trust me. I'm not lying. That product of those two binomials multiplying each other, if we used FOIL, you will get right back to the original trinomial. If you do feel a little lost in a problem and you're like, pretty sure I'm doing this right, but I really don't know. I don't know for sure if my answer is correct. What you could do is just simply go back and FOIL these two binomials. And then if you do get back to x squared plus 10x and then plus 24, you know for a fact that your AC method was done properly. Okay, so I'm just going to write. It's not going to be a ton of stuff. There's a lot of words. Kind of wish I'd copied and pasted. Okay, so this is just to kind of, so you have it written down. So, AC method, okay? The form it needs to be in order to be able to do the AC method is going to be ax squared plus bx plus c. And just to make a note, b and c can be negative. Okay, another note, this is where a is greater than 0, which means it's positive. Okay, that leading term right out there in front needs to be positive. B and C, they can be negative. It doesn't matter. It doesn't matter if they both are. It doesn't matter if one is. Doesn't matter if they neither are. If they neither are, then it's all right. You know what I mean. But just keep in mind, if you see a problem and you do see some negatives, you just don't want that leading coefficient to be negative. Okay. Now, let's see. So that needs to be the form that my problem is in, right? So what we do is identify your A, your B, and your C. And then after that, we're going to, meant to do an M, multiply A times C. We're going to factor our product. And y'all, that came from multiplying A times C, right? Multiplied them. The answer is a product. We're going to factor that product. Okay? Then we're going to choose a pair of factors that combine to be. And then what we're going to do is we're going to rewrite original, that's an L, original trinomial Original trinomial replacing b with new factors. Okay, so then we're going to replace our b. We're going to rewrite the original trinomial, but we're expanding, right? We're replacing our b term with those two new factors. Let's do this, including variables. That is very important. And then what you're going to do is factor by grouping. And this is our 13.1 video. Okay, so I have got 4 more examples that I'd like to do for this section. So I'm going to go ahead and record them now. Okay, thanks y'all. Bye.